Linux starting and ending cylinders. So it's also flagged as 83 Linux, but no file system is there. That is a default partition type, 83 Linux, when using parted. So we are now ready to overlay a file system, EXT4 of course. So the next step is to use the make2fs program. Now it sounds as if it makes extended file system version 2 file systems solely, but the various file systems supported in the EXT version tree, including 3 and 4, are supported by make2fs, so long as you indicate the type with the T option. There are also shortcuts to the distinct file systems available that we can run to make those particular file systems. We'll show you that momentarily. They include makefs.ext2, ext3, ext4, etc. So make2fs, type ext4, journaling, and the location of the partition is in the dev tree SDB1. Note that this is not an LVM partition, so it will not be a candidate to be allocated to our current LVM layout. It's simply an ext4 file system that may be accessed outside of LVM and mounted somewhere within your tree as block storage. So this is one way to do it. This overlays ext4fs on dev SDB1, and then that leaves us simply with mounting the file system and then creating content, and of course updating fs tabs so that upon reboots or run level shifts the file system is made available. So let's try this out. And as mentioned, ext4 is now the default with Red Hat Enterprise Linux version 6, and it supports a number of additional features over ext3, including one of my favorites, and that is nanosecond time precision of objects created within the file system as opposed to second precision, which is a huge difference, 10 to the 9th difference. So let's go ahead and generate this file system. It's only 10 gigs, so it'll be generated rather quickly. And Tune2FS will check it every 180 days, or you can run it manually, so on and so forth, or every 38 mounts, which is roughly, if the system reboots every blue moon, maybe every year or so, maybe even more. So with that said, let's go ahead and take a look at the file system using fdisk-l dev-sdb1 or dev-sdb. Still the same information, parted-l. Scroll towards SDB, and it shows that it's now ext4. So it's ready for prime time to be mounted somewhere within the file system. So we'll create somewhere to mount it. So make directory off of the root of the file system. Let's call it temp10g1 to indicate that it's the first 10 gigabyte storage partition that's made available. So this will be our temporary mount point. It can be mounted anywhere in the file system that you'd like, including places that contain data, so long as you find a way of copying or moving the data over first. So let's make this temp10g1 and then follow up with a mount command to make the partition available for general usage. So we'll mount, and it's type ext4, but we don't have to specify, and that's going to be dev-sdb1 in temp10g1. And let's go ahead and echo this at the shell, and let's just check. That should be temp upper g1, so we'll update our notes, and let's mount. We should see that type ext4 file system has been mounted in read-write mode, temp10g1. So that's now available. And let's just note that we executed the mount command to confirm that it's mounted. So at this stage, what's left is for us to create content. So create content in new repository. And that's quite simple, using sequence, for example. Now before doing so, let's navigate into temp 10G1. You'll notice that the root of every new file system is a lost plus found directory for orphaned items that are created over time. And LSLA, there's nothing hidden other than the upper and current directory entries, and we're available to write content. df-h shows the size, which is an estimation, how much of which is used. Of course, there's some storage used for the management of the journal of the file system. So there's always a percentage, roughly a percent to 2, that's sacrificed to manage the journal provided by EXT4 or 3. And how much available, which is the bulk of it. Let's write some data. And that'll create some data in the storage repository, which is now available with typical permissions written by the user root and owned by the user root, but readable by all other users on the system. So now we have provisioned additional storage. What if we wanted to provision even more storage? Simply repeat the process. Using the same disk, for example, we would start at 10 gigs and go to 20 gigs. So 3 repeat process on the same disk. So using parted, let's go ahead and make that happen. Dev SDB, P to print, and we want to make a new partition, so make part, but don't have to remember, just type help. Make part, and it's primary. We can do 3 primaries and then 1 extended to hold, and number of logical. And we want to start at 10 gigabytes and go to 20 gigabytes, for example. So this will provision the new state, or the new amount of storage that is. And it threw an error concerning making the new partition space. And this can be worked around sometimes by remounting, but in this case, notice that the most it can manage is 20 gigs to 20 gigs, so we'll tell it no. What it wants us to do is to flush the kernel, which usually occurs via a reboot. So notice it attempted to create it. It seems as if it's there. So we can try to overlay a file system to see if it works. So it threw an error initially to say it had a problem writing. In fact, let's just clean it up using remove just to be sure we don't run into problems. It actually did it. And let's try it again. There is a command history. Sometimes this doesn't work. And sometimes it's just an overlapping issue, which is why I tried 11 gigs to 20 gigs. It appears to have created it, so we'll try to use make 2fs to overlay the file system. If that doesn't work, then we can always switch the disk. So for example, if we select dev SDC, this changes the disk. Now let's try to make the part here as well in the event that that one doesn't work. And it's primary 1 to 10 gigabytes. Notice it works on dev SDC, and that's because we've just made changes to dev SDB. So the kernel hasn't released those changes yet. So we have another partition in the event that dev SDB2 fails. Now let's quit. And we've mentioned that there's some other tools. Makefs dot the file system type. If you'd like to overlay, let's say EXT4, you can run makefs.ext4 followed by the target file system. This is an optional way of laying out the file system. So EXT4, if you run it with help, it shows the same options. And we want to turn this on for dev SDB2. Let's see if the kernel will allow us to write to it. And it doesn't, so let's try SDC1. That works. So indeed, we may need to reboot the system in order to be able to write to SDB1, or to perhaps redefine the partition and then create it. So now we've created it, let's part it L to see what's on SDC. And there is the first partition, and that's the wrong space. Let's go up, and where's SDC? Here's SDC, there's the first partition, EXT.